All right, welcome everybody. This is Peter's fourth training session on Designer. We've been doing the basics and then digging into the tree and the tile components. Peter's now going to this week give us a actual example that we will then deconstruct and see how it's made and how it can be modified. Peter.
Okay, so yeah, we've gone through all of the components, and we've talked about all of that kind of stuff and the way the interface works and everything. And there's largely a lot of kind of fairly dry stuff to get through. It's necessary because it's going to help us to just understand where we're going to go from this point. But from now on, what I'm really hoping to do is to get into some interesting systems, do a bit of exploring, and really show where the strengths of Designer are, and also make it kind of accessible in such a way that you don't feel, that it's overwhelming. Because really, as I keep on saying, it's all about understanding small steps and combining those things together. And so the way I thought we would start out is to take a system which is not one of the most complex systems I've ever done, but it's a system that's built up of very, very many parts. And so that you can kind of see that really this is really quite simple. It looks complex, but it's really just lots and lots of repetition and lots of little bits and pieces all kind of nailed together. And so I'm not expecting that, you'll be able to kind of build something quite this complex, but we're going to go into it and look at it and just see what it's made of and how it works. And I'm also going to show you one of the things that I think is one of the strengths of both ArtMatic Designer and also ArtMatic Voyager. We have this situation where software is often used as a kind of a goal-based thing, where you say, I want to make this thing, and you set off, heading off into a certain kind of goal and making that thing. And then there's a whole other way of working that everyone's familiar with when it comes to something like Designer, which is completely random, where you can just plug away and you can get all kinds of fabulous random things happening on the screen. But there's kind of a third way too, and there's this kind of middle way. And it's one of the big strengths of both Voyager and Designer, and that is where you can have a goal, but you can let the process inform your goal in a really, really beautiful way. You can actually use kind of constrained randomness, and you can use an exploratory path to get to a point where you'll come up with something that you could never have imagined in your head you would be looking for. And my Space Girl, as I call her, is a really good example of that. Whereas initially, way back in the day, so we're talking maybe 12, 13 years ago, and we had a Topica list for ArtMatic. This is actually even pre-Voyager, so it's probably longer ago than that. Someone had made a criticism of ArtMatic, saying, oh yeah, but it has an ArtMatic look. You have this look in ArtMatic and everything looks the same. And I said, well, no, it's not really. It just depends on what you choose to do with it. And I showed a few examples of things, and they were kind of critical about it. And they said something along the lines of, yes, but you couldn't do something like build a face. And of course, no one really should say that kind of thing to me, because it means that I'll suddenly go, I reckon I could actually. And so I set about building, initially I built a little monster face. It was very simple, and I think the tutorials for that are still around somewhere. And then the Space Girl came out of that. It's basically a much more complex version of that original monster face, but it uses exactly the same principles. So I'm going to let you see inside this, in this system, and see how it's made, and see that it's actually quite simple in many, many respects. So one thing that I'm going to tell you, which probably will be surprising to you, is that this whole thing is built out of that one object, my favorite little Gaussian circle. Every single element that you see here is built from Gaussian circles. There's nothing else except Gaussian circles as the basic building blocks of this face. So let's have a look at how it's kind of like composed. Here we are. So we have many compiled trees here. We're going to go down and down and down into the compiled trees. And if you don't know what that means, is we have components in ArtMatic, which are the standard components, but we also have this kind of component, which is a compiled component, compile tree. And that when you see that shape, that means that there are other components hiding inside there. And we get into them by typing. It's a toggle with the E key. So if I type the E key, we'll go inside there. We're now seeing what's inside that compile component. So I make a habit of naming all my compile trees, and I think you'll probably understand why once we've really fully investigated this particular system. So this one here is really just the top tree, and it's set up in such a way that you don't really need it, but the reason that it is in this top part of the tree is because I wanted to put a hue shift component into it for certain reasons, but I've got it all locked, as you see, so I don't even really use it. But it can be useful. The hue shift is just a color component. If you've been following the previous tutorials, you'll understand straight away that we're looking at a 3 output tile at the end here. And once again, we're in the topmost part of the tree. And that means that we're dealing here with RGB values. We're not actually using the color palettes here. So if I choose a different color palette, you'll see nothing happens because these values that you're seeing, the color values you're seeing in the face, and the color values that you're seeing in all the versions of the face that I've got down here in the keyframes are all controlled by the RGB values that are being assigned inside the system. So let's go we'll go one down and we'll see where we are when we go one down. So we've dropped one level down. One of the things that you can't easily do in Designer is know where you are in the system, which is why you should name everything, because we can keep on dropping down and dropping down. And I'm not even sure how far you can do this, but I do know that I have made very complex systems and I've never run into a problem falling down one more layer. Each time I go down a layer and I make a new one, I'm surprised and I go, okay, I've gone one more down and I'm still not having a problem. But of course, it becomes very complex as you drop down because you need to know where you are. So we're down one layer at this time, and you'll see that I've called one of these compiled trees the complete face. Just looking down in the tooltips down the bottom will show you the names. And then the other one I've called mask patterns. And that's because this system is actually largely two discrete ideas. One of them is the face part itself, and one of them is the patterns that you see arising around the face. They are two separate pieces of what's going on here. And they both have their own color components to them. The face is largely a monochrome face, and the color is largely controlled from the mask patterns. I could do this in color, but I haven't. One of my future projects is actually to recreate this face, but then using color components for the facial part as well as for the other part. So for the time being, we're just going to forget about the mask patterns and we're going to go straight down into the face and have a look at how that works. And I'll just tell you, these two here are both RGB. As you can see, they've got their little RGB outputs. They are being connected together with a mixing component. And if you look down at the bottom, you'll see this is a packed vector maths component. This is just a mathematical comparison component. And I've selected as this component the multiply algorithm. So what's happening is the two streams coming down here are being multiplied together, and that's they're multiplying the pixel values together. There are many ways you can join these values together, but in this case, that's how I'm doing it. But that's a mixer, and you'll see straight away we're looking at this tree in that format that I pointed out earlier. We've got a space transform component at the top, which basically in this case will just move the whole thing. So if I just do this, it'll go, whoopsie, a bit too far. It just moves it from side to side or up and down if I use the Y value. So it's space transform. Then we have our objects, which is the things that it's made of. And then we have some compact tiles, which put it into a mixer. And then down the bottom, I've got another color tile, which in this case, I don't actually need. I can quite easily disappear that. Oh, I see. It's just, it's doing something with the scale. Or I have done something with the scale. I can't remember what I did there.
Control Z to undo.
I just did undo it. It didn't undo that for some strange reason. Oh, there we go. It needed another undo. There are 4 levels of undo now. We used to only have 1, so I reflexively only ever undo once. I keep forgetting that I can actually keep undoing now for 3 more times. Yeah, so that is doing something there. It shouldn't be, because it's not actually. Anyway, let's forget about that. Let's just drop into the left-hand side, which is the actual face components. And I've called that, as you can see at the bottom, I've called that complete face. So once more, whilst this component is selected, I'm going to type the E key, which will drop me down 1 more level. So you see we've now fallen down 1 more level. At any particular time, you can get to the top part of the tree by hitting the escape key, and you'll go all the way back right up to the very top of the tree. But here, we'll go down 1 level into E, and then we'll select this one and we'll go 1 level down again. So we're now 2 levels down in the tree on the face side. And you can see there are 2 more compiled trees here. One of them is called eye light, and that's the tiny little eye reflections. And the other one is called face components. Now the eye light is a separate thing to the rest of the face components for one simple reason, and that is because the face is controlled by symmetry. It has 1 axis of symmetry all the way down the middle, and I'm only really working with components on one side, which are then dictated by this tile here, which is giving it bilateral symmetry. But the eye glints here are not symmetrical. They're actually offset slightly. They're not kind of mirror image of one another. So they've had to have been composited as a separate element because they're slightly offset to the right. But everything else is bilaterally symmetrical, and that's all being taken charge of by this component here, which is just basically going mirror on 1 axis. And if we look into it, you can see the branch number here is 1, which just means flip it that way once. So that's a really good thing to. Yeah.
Just one question. I noticed that those 2 compiled trees, where they connected to the mixer underneath, they cross over, if you like. So the one on the right-hand side moves to the, say, the x-axis. How do you figure out which one of those makes the most sense?
It kind of depends on what you're trying to do. In this particular case, I just look at the component. It may not actually make, yes, see, I've scaled the values. So it's basically taking in two streams of values, one into the X component, one into the Y component. The reason that this has happened in this way is simply because when I was making this face, and I'll show you a little trick here, I'm going to connect, so you can see these 2 components are mixed together via this mixer. So this is the one that's controlling the eye light, and this is the one that's controlling the face itself, the symmetrical face. I'm going to bypass this, and I'm going to show you how to do that. I'm going to just select on this tile. Now I'm going to command click on this tile. Oops. And it will zip past that mix component and straight into the main component. And you saw immediately what happened, right? The eye glints have gone because the eye glints are no longer mixed into this path. So I can tell you that, and this is kind of like a little bit of archaeology of this particular system. I can tell you I've been working on this system, and then at some later stage, I've decided that I needed to add the eye glints in at this point. And so I've added them using a mixer. Why it's flipped around like that, I'm not entirely sure, but let's have a look by reconnecting it. So I put the eye glints back in. It also had another effect there. Did you see? Yeah, something in the mixer is actually having control over how those things are added together. Just change something very slightly there. And these are the kinds of things that can happen because the systems get very complex, and the kinds of things you're mixing together are all either additive or subtractive or multiplying. So you figure these things out as you go. And then when you get to a certain point, you'll do something like I just did then, and you go, I don't know why I did that. And it's because the system's been built up in a process. And so taking something out is asking you to solve a very complex problem in your head, which you may not be able to do. So I'm going to flip these 2 XYs around and just see if I can figure out why it's the way it is. oopsie, why did that happen? Let's just go. So to get that menu up, I'm talking to that component by highlighting it. I'm clicking on that, and then I'm selecting the component that I want to reconnect using Option and Command. Oops. And you can see that this one is connected to the right-hand side. So I'm just going to reconnect it to the left-hand side, and I'll disconnect that side. And then I'm going to reconnect the other side back in the same way. So I've just swapped them around now. And there is something to do with the way the mixing is happening that's kind of changed everything. The scale is all added, so is altered. So let's just go back. So I just reset this at the nominal reset, which is reset all to default. I've got my face back again, and you can see the eye glints are there, but they're not that strong. So if I just scale the Y a little bit more, maybe that'll, are we in the Y? And that's the face components, okay. Go undo. Oh. See, and my undo's not working there. Don't know why that is. So let's just reset that. Let's just reset that. Okay.
Looked like you had the face back and the glints back in that last.
I've lost this now for some reason. I've changed the scaling. There's a whole lot of different things going on here as well.
Your inputs are still flipped from where they were before as well.
Yes, I know that. So there's a bunch of things happening here. So you've got a mixer here, but I've also used this component here for some reason to rebalance something. When I say something like for some reason, it's usually because I've been working on something in my head and I thought, I need to put that component there to kind of rebalance something. But I've forgotten now because it's been so long since I've actually worked on this. But I can tell roughly what I did, because you saw I got it back again. Because I noted before that the scaling had been changed. So scaling is actually going to control both of the values going together. I'm just trying to find out if I can get that eye glint stronger. So the eye glint is here. So theoretically, if I bring up the X value, we should get a stronger, yeah, there it goes. It's now stronger than it was. So to answer your question, Andy, archaeology, that's the only reason they were flipped.
Okay.
So flipping it back again makes no difference. But of course, you will understand that the X and the Y values control different things if the thing's flipped. So now what would have been controlled by the Y value in the older version is now controlled by the X value because I've flipped them back around. But essentially, it's still just mixing the two streams together. And then I've rebalanced it for some reason with this scale component. I'm not absolutely sure why that is. It's probably to do with the luminance values of something. You can see that it does have a fairly large effect. But anyway, let's just pretend that isn't there for the moment, and we'll dive down a bit further into the face. So I'm going to not look at the eye glints. I'm going to jump down into this component, and as you remember, this is now bilaterally symmetrical according to this component. Oh, I'll also explain why there's a noise component at the top here. So what does this noise component control? It seems like it's weird because it's not doing anything in particular. But if we move the phase of the noise, you'll immediately see what it's controlling. It's actually controlling very slight distortions of the face. And the reason that that's there is because faces are not fully symmetrical usually. So I put that in at a later stage. I've probably not had that in there while I was working on the face, but at some stage I've thought to myself, I want to add a tiny little bit of a distortion to the face so it doesn't look absolutely symmetrical. And if you look at the face, you can actually see it. It's very subtle, but the nostril is not quite symmetrical. The eyebrows are not quite symmetrical. Those kinds of things being added into something give you the ability to just add another level of realism to something. If I take that entirely out, let's just swap it with something. It's offset slightly on this now because of various problems. What I really should have done, in fact, let's do it because it's probably instructive. So I'm going to undo that, and I'm just going to, let me see, and actually I'll leave that the way it was. I'm going to pop back out one level in the tree. I forgot to copy it. I need to copy that. I'm going to copy that component. I'm going to then change it to just something that's a bit neutral. I'm going to jump out to the top level of the tree, or the next level of the tree. And here you see I've got the face and the halo effect. I'm going to relocate the face so that it's in the middle of the halo effect here. It's not like that. Oh, by the way, I'm doing this in small increments. This is another thing. So what I just did then was I grabbed that component, the offset, and it offset way off because I just clicked on it. But if I hold the Option key down, it will give you the ability to move it in small increments. So now I'm just adjusting it so the symmetry is correct for the two elements here. And I'll pop back out again because these two things was just slightly offset from one another. And now I'm going to put that noise component in here. So it now controls both the halo effect and the face, which is what it really should be doing. It should be actually doing this. And if I move the phase very slightly here, you'll see now everything is actually distorting. That's a more logical place for that component to be, so that it's actually moving everything, and the actual, what I call the mask, is not, the space mask is not moving around. And this will be the case with everything. So it will, all of these keyframes will work the same. I think, can you see that it looks a little bit more natural? It doesn't look quite as, it doesn't look like artificially symmetrical as it would if I did this. That's just very symmetrical now. So having that in there, can I get back one? Yes. Having that in there just gives me that slight level of, you know, human realism that we would like to have. Okay, so that was a bit of a distraction, but copy paste is really useful for doing that kind of thing. That's another thing to keep in mind, that if you've got here's a thing that I often do actually, just say I wanted to change this tile to something else, okay? And I didn't want to lose what I have in here. I've got these settings are actually in this tile. But let's say I thought, oh, I could do something real fun here by putting in I don't know, another distortion of some kind. So I can do this. I just add another tile here, and I'll copy and paste this to that tile. Just leave it there. It's not connected to anything. Now I can go, well, let's try a skew component in there. What does that do? Don't really like that so much. Let me try another branch component. What does that do? Oh, that's weird. Okay, hate all that stuff. Just copy paste this back again and get rid of it. So it's like using the component as a little holder. So you can do that at any time. You can, if you're playing with the system and you get to a point where you think, I'm just about to make a lot of big changes to this. I don't want to lose them, but I just want to have it handy there. Just make another component and use that as a copy. Another reason you might do that is if you've got a mixer or something and you like this mixer, you like how it's set up, but you don't want to lose it. You want to kind of keep it somewhere. So you can always just park it. Just make a component here, make it a 2 in 3 out, copy this, and just park that component there for future use. It doesn't do anything because it's not connected to anything, but you can just keep it there because you might go, I want to remix something down here and I want to use the exact same settings that I had. So it's really good to keep that idea in mind, that little parking of a component. Okay. So where did we go? Let's drop back down into the face again. So our eye glint is here, our face components are here. I'm going to fall down into the face components themselves. And you'll see one of them I've called face. one is called eyes, one is called mouth, and one is called nose. And they basically compose the whole face together. If I drop into this one, you'll see I've got a group of things here: face shape, which is the basic face shape, the jaw shape, and the cheeks. And they all compose different parts of this thing, but each of them, if we're dropping down one more level, each of them is a Gaussian dot. That's all it is. So these three components controlling each of these parts of the face are all Gaussian dots. So my cat is annoying the crap out of me here. What are you doing? Go out.
Must be hungry.
She just likes to have a say sometimes. Yeah, so let's have a look at what each of those things actually does. Now, remembering, we're only looking at this basic face shape here. So I'm going to drop into it. That's the top part of it. It's very simple. It's just a circle. Drop into this one. This is, what is this? This is the jaw. Oopsie, I just jumped up several things then. So this is the jaw. I'm going to pop into the jaw. You can see it's being controlled. So it's an object. It's being mixed outside there with something. So that's a mixer. That's an object. The object is just another Gaussian dot. And the shape of it is actually being controlled by some noise and by a distortion tile. So let's just go a bit radical here. I'm going to radically do that. You can see these are fairly subtle changes because they're subtle shapes, but it's actually moving that bottom part there into different areas. You can see that, I think. And the noise, again, is just distorting it in certain ways. And I've used that just to control the shape of the jaw. Now, remembering, when I started building this thing, I would have actually just been making the face shape first. So that's all that would have been there. And in fact, we can look at that, I think. Let me just try and look at the face shape. Yeah, so here's another trick. So there's no actual way to switch off a component in ArtMatic, and it makes sense because everything is so complex and is controlled by so many factors that just switching off a component sometimes would have like radical and undesirable effects, and it wouldn't help you. But there are shortcuts to be able to see certain parts of things. So if I take this component, and you can see it's the mixing of a bunch of different things down here, but I can just connect it directly to the face. Again, by doing that thing that I told you, just select on the component and then option clicking, and you'll see it's just the face component. Actually, I've got this halo here too. So let's go back right out to the top of the tree. I'm going to switch off this side of the tree as well by doing exactly the same thing. This will have some fairly large effects when I do this because this component is actually controlling a lot of color components inside this tree. So it's, first of all, it's going to probably all go to white and it'll probably be overexposed, but let's just try it. Yes, that's because there's lots of mixing going on here. But let's leave it for the moment so that I can just show you the face components, okay? So I'm going to jump down back into where we were with, so that's just looking at this one tile, which is made up of these three parts, and they're all Gaussian dots. This should allow us to see what effects are happening here a little bit more radically. So here's the skew. It's just changing that bottom part of the jaw there. It's also working in conjunction with this noise. So this is just giving it subtle shapes. That's the jaw. Oh, that was the cheeks rather. This is the jaw. It's only one component controlling this, which is just a tilt. You can see how I've worked this so that I've made the shape of the face the way I wanted it to be. And we'll go back into this one, which has essentially just got the dot in it. So there's nothing affecting that. It's really just a circle that's sitting there somewhere, which I'll show you just by moving it off. Oh, Yeah, so it's moving outside the symmetry when it does that, but basically I can move it to the side. You see, it's just a circle. And the reason it kind of has that kind of blending effect is really just to do with the way the mixers are mixing it together. So these mixers here blend the values together in such a way that you get that shape. But after we finish this part, if we have enough time, what I'm going to do is we're going to start one of these systems from scratch, and you'll see how these things all join together. Okay, so I won't dwell on it here too much. We'll go back out. I'll reconnect us here. I'll go right back out to the top, and I'll reconnect us, whoopsie, here. So we're back at our face. Did that make sense, what I just did then? Did you understand all of that process?
Yeah, I think so.
Yeah.
Yep, good.
Yep.
Okay, so I'll keep diving into this side then. So back into the face. So we saw that's the basic flat part of the face, the way that it's built up for a structure. And that's how I started with this system, essentially. I just started with those Gaussian circles and I built them into what I thought was a reasonable shape for a face. That's how it started. Remembering once more that everything is controlled by this symmetry. So I'm really working with the symmetry as well. I'm using the symmetry to do some of the work for me. If I take that symmetry out, we'll end up with half a face. And you can see there's some weird shit going on down here, but I don't care about that because that's all on the side of the symmetry that I'm not using. All right, so let's dive back in and have a look at some of the other bits. The eyes, which are made up of more components. So let's just go right back in here. Oops. And you can see that each of these components do certain things. One of them is the shadow, which is that kind of socket shadow. One of them is the whites of the eyes. One of them is the iris and the pupil, and the other is the eyebrows. And once again, if we dive into these, each of these, there's, oopsie, that's two joined. Once again, you can see that's our Gaussian dots. All, again, it's nothing but Gaussian dots, all made, joined together in some way or other. They're distorted in various ways. So here we have the eyebrows. I've stretched them fairly considerably, and then there's some phase to control the shapes of the eyebrows. You see a lot of them don't work, but this is a matter of going through and finding something where you go, okay, well, that's a shape that I quite like, and using that. It's just kind of a sculpting process, if you like. The iris and the pupil, again, you know, there's the iris that's around that side there, and then there's the pupil, which is in the middle. Again, they're just dots, and they're kind of added together in different ways. So this tile here, this AX plus BY plus C tile, is just a very simple mixer. So it allows you to actually add things in a positive way, but you can also subtract things. So to make something brighter, you add it. To make it darker, you subtract it. So obviously the pupil is quite dark, so it's subtracted from the thing that's behind it, which is the other part of the eye, which is also quite dark, which is subtracted in turn from the next step up, which is the whites, which actually it's being subtracted from the combination of the whites and the shadows. So do you see, it's just a process of adding and subtracting things to make them look the way that you want them to look.
Sorry, how were you doing that subtracting?
It's all done in this. This is a mixer tile.
All right.
So let's just pop right back out to the top of the tree again. And we're just going to have a look at these two, because this is a good way of understanding that. So I'll let the thing go. So this is here, what's going on is that I've got it mixing two values together, the values of the main face and just the dots for the glint, these little glints here, right? So the dots for the glint are coming in on the X value, and I've got them racked right up as high as they can go here. But if I pull them down, they'll go black, because now this is a negative value.
Right, I'm with you. Yeah.
So when it's in the middle, it's its normal 0 value. It'll be completely gone, because it's not adding or subtracting. Going to the right of it is going to add it, which will give you added values, and going to the left will subtract it, which will make it black.
Yep.
So it's one of the simplest of the mixes, this one, because it just basically goes X value and Y value and whether or not they are positive or negative, really. And then there's an add control, but you know, a lot of the time you don't need to worry about this when you're just using that mixer, because you're only interested in the two values, the X and the Y. So this one just sits at normal most of the time. Obviously you can find out the exact things that these components do by hitting that Command F thing, and it will take you into a browser, and this tells you exactly what it's doing. So it scales, mixes both input and adds the offset, which is the last component. So if you ever need to find out, you know, the exact maths of anything, that's how you do it. You just click on it and you go Command F, and it will bring up the browser, which will link you to exactly what that particular component is doing in a mathematical sense. It's a very simple one. It's the simplest of all of the mixers, basically. But if you look in a lot of the systems that are in the library, the ERIC systems, you'll see these are there all the time. ERIC uses them all the time to mix things together for various reasons. So it's a very commonly used particular component, that one. Oops, where do we go there? So once again, you can see that I'm just jumping down through the trees here, and you can immediately see, I think, how complex this can become. The more components you have that are embedded and compiled, the further down you go, which is why it's very important to actually make sure that you name all of these things. But essentially, all of these aspects of the face, so the nose, the mouth, the eyes, are all just versions of adding or subtracting distorted Gaussian circles. That's really all that it is. And the only different thing in here that kind of is acting in some slight different way is, you'll notice if we're in the eye component, oopsie, you see how easy, if you toggle in the wrong place, you can flip right back out of something. So you have to be careful of that. But I'm going to look back in the eyes again, and I'm going to zip into the iris and the pupil. I just want to show you one further thing. You'll see this component here, which is, it's a plateau component. And this is really good for, so the Gaussian circle itself is quite a soft component. It falls off in a Gaussian equation. So it's very soft. But you can actually change how much it falls off by putting in this plateau this component, which allows you to change the actual fall off amount. And I've used it here, you can see, to give sharper lines between the pupil, the iris, and the glint. They all use that plateau component to give them a little sharper edge. Everything else is quite soft, you'll see, which kind of works quite well when you're doing something like a face, because you're shading. It's like all manners of shading. This is not like a hyper realistic face. It's just a kind of a cartoon looking face. So, you know, it's not trying for hyper realism here. That would be it would be achievable, but you'd have to spend a lot of time doing it. I'll pop back out because I've spent a lot of time talking about this. I just wanted to show you the other component here. And this is a really important part of the strategy of working with ArtMatic, I think. And that is, this is the component that controls all of the halo stuff. Now, here we've got, it's a considerably different looking style of thing. It's, again, using the Gaussian dots. This whole thing is built of these Gaussian dots. In this case, I'm using the color version. So it's not just the 2 in 1 out version. It's now the 3 in 4 out version. It's essentially exactly the same, but it has one difference, and that is that it gives you a color cycle that you can set. And that's how you can get some color into the dot. There is another way of getting color into the dot. We'll look at that in a minute, but this is just a quick way of doing it, using the color version. And inside here, you'll see there's a fair bunch of tools to manipulate various things. There's some symmetry tools. There are some color tools. There's some more of these plateau things, which are giving sharper edges. And I won't go and explain exactly what everything is doing here, just enough to say that it's creating all of these kind of soft designs, which are distorted and colored. And the main reason I want to show you this is because it uses I'm using one of the tricks that is really fantastic for this piece of software, and that is to allow a certain level of constrained randomness to come to play. So you'll notice that you've probably been noticing in this system that everything is locked. Nearly everything is locked. There's a little bit of constrained random, and that is every now and then I've got something that's unlocked. Here it's some color. Here is some color. This is a hue shift. Here it's the phase of the noise. And when I move these, you'll see what's happening. Those are controlling certain aspects. That one's not visible. There should be another one in here, I think. Certain aspects of what's going on there. And the reason for that is that I can play with those things manually, of course, but I can also do this. I can hit the mutate tree and it will go through and it will mutate just those things. So the face pretty much stays the same, although one thing that does mutate in the face is the eye socket shadow, which I've allowed a little tiny bit of mutation to creep into because it gives a slightly weirder look to the face. But mostly it's this kind of halo effect. And this allows me to kind of jump through here and find things where I go, oh, I really like that, and then add that as to my keyframes to keep. And this constrained randomness is just a fantastic exploratory tool. And I use it all the time when I'm making ArtMatic things. I also use it in Voyager because it's really great for doing certain things like getting unusual shapes. If you've got a DF shape, you can actually put a little bit of constrained randomness into it. Then you can mutate it and you can see what effect that has on the actual DF object when it's inside of Voyager. So this allows you this enormous amount of exploration. It also is fantastic when you come to doing DF fractals, because when you're using 3D fractals, you can actually allow a little bit of randomness to creep in and it can lead you into all kinds of really wonderful explorations. So you're controlling what's going on. So you have the control to know, what you're shaping, but you're also allowing the randomness to come to play to help you get new ideas and new outcomes and things that you probably wouldn't do if you were kind of setting about doing it, on your own. So I'm going to leave this system now. I think I've kind of talked about it enough because I just wanted to get on to just building a really simple system from scratch. So are there any questions while we're at this stage before I go out of here? Yeah.
Yeah, I've got a question. What was your inspiration to do the sort of the way you constructed this? Have you done it before, or did it evolve over time as you, what if I do this, what if I do that? Or did you have a set, I know I can do this by doing that, and then you constructed it the way you did?
So, initially it came about because I wanted to see, what I could do in terms of making a face inside of ArtMatic. And, as I said before, I built the simplest versions I built were the monster faces, which really are quite simple. And there is a tutorial you can follow that will step you through the process. It's worth doing it because it is quite simple and it doesn't take that long. So once I'd done that, I started realizing, that the symmetry thing is, that's pretty obvious, and being able to do all that kind of stuff is pretty obvious. And then I wanted just to add some more elements to it. And I thought about, adding some of the halos and seeing what I could actually do in a sense of sculpting it in a way. So that side of it is just about then adding the color components and trying to add that kind of stuff to it to see where it went. As I said, I have a further thing that I want to do where I want to rebuild the face, and this time because I mostly built this out of the one out monochrome Gaussian circles. That was a long time ago, before the color versions actually existed. So I've never actually built this face with the color versions. But of course, if I go into the color versions, it should be now completely possible to do things like change the iris color to what I want it to be, or even have a constrained mutation on the iris color. So it mutates with every version to a different color, just the iris color. So that's one thing I could do. I could probably put shading on the lips, so I could actually have, you know, colored lips. I could put shading on the skin tones. There's all kinds of other things that, you know, can leap to mind. You could put textures on the skin tones. There's all kinds of things you could do. So it's just a matter of, you know, how much time you want to spend on it and how inspired you are to try and, you know, change it up to something else. So it started out just as a basic, simple thing where I literally just had like a circle and two eyes and a mouth to see whether I could make a basic face. And then once I did that, I realized, you know, I could kind of extrapolate on that and go get quite complex with the face if I wanted to. And I know now, right, you know, as I'm doing this, I can tell you I could get even more complex with the face if I really wanted to spend the time on it. It's not hard to see how you could get some quite interesting shading on the face. I can see, for instance, there would be a way where you could reassemble this face in a different way, and instead of using the kind of soft Gaussian shaping that I've been doing, you could bring into place some of the derivative functions and get a more 3D looking face. So I can see that that could be possible, and I might try it at some stage to see exactly where that goes. You know, it's just you know, that's the great thing about it. All these things are possible. It's just about how much you want to explore and play with them.
And I suppose you could also use sound input and have a way to animate the mouth so that as you spoke, the mouth moved and it looked like the face was talking to you.
Yeah, you could do something of that nature. Absolutely, you could do that. Yeah, absolutely, it would be totally possible to modulate the noise functions with sound input. That would, I'm not sure you'd be able to get exact lip sync, but you'd certainly be able to make the mouth do something in conjunction with a sound input. There's no doubt about that at all.
I've often thought with that about generating mouth positions and the short animation segments around it, and then doing the old animator's trick of pulling it into a video editor and picking these segments that then match.
Yeah. Well, you could see, the thing about it is you could theoretically do that with animation inside Designer if we had like a scalable keyframe thing. At the moment, the keyframes all take up the exact same amount of time. So if you've got 16 keyframes, they take up 1/16 of the actual time of the animation. But if you could put in time-based animation, you could animate the mouth to speak. You could certainly do that. I could do that.
Could time it if you repeated keyframes.
Yes, you could just make up mouth shapes and place them in where you wanted them to be. It wouldn't be that hard, but it's not possible currently. All right, so what I'm going to do now is I'm just going to go back into my kind of really basic system. We'll start from absolute scratch with our Gaussian dot. So essentially, I'm going to stick in with the. Well, no, hang on. Let's try it with the color one. Let's go completely wild here. So here's our Gaussian dot. When you're using the color version of the Gaussian dot, it defaults to neon light disk, which is really lovely, but it's not the same as the Gaussian disk that we've been using. So I'm just going to bring it in as the Gaussian disk. You'll see that it's on a transparent background at the moment. So what I'm going to do is I'm just going to make it so that it's just the same as the Gaussian disk we had before, but here I'm going to take away the alpha channel so that it's on black. Okay, and the way that I did that, basically, the alpha channel travels down on that fourth input. So if that fourth input is unterminated, the alpha channel will always be visible. So by putting in a 3 output tile, I've just removed the alpha channel. It just doesn't have access to it anymore, so it'll just go black. So here I'm going to just show you how to kind of combine a few different versions of this. So let's put in, one of the things that I often do is I'll put in a tile at the top of the tree, which is just, oopsie, that wasn't where I meant it to go. Let's put it there at the tile of the tree. Oh no, that doesn't work either. Let's make this a 3 in, 3 out. And that's just a joining thing that sometimes doesn't work properly when you make a tile beforehand. I'm going to lock everything. To do that, I just hit shift and click on the lock, and that just locks everything. I'd really dearly love it to default to what used to happen, which was whenever you made a tile, it was made with whatever default you already had in place, like everything locked, everything is made locked, but he's changed that for some reason. And I'm going to make a second branch. And to do that, I just hit the B key. So that's for B for branch. And I'm going to change this one into a 3 and 4 out. And I don't even have to go and select the Gaussian thing because I've changed stuff in it by making it into a Gaussian disk and blah, blah, blah. I can just copy it and I just paste it across to that one. So I've now got a second one, okay? Now I'm going to make another one. Same deal again, 3 and 4 out, just copy that and paste it. And I'm going to also put a 3 out tile there. I'm just typing the 3 key to do that, by the way. If you want to put in a tile underneath the one you're on with a certain number of inputs, just type the number of inputs that you want, the number of outputs that you want. So if I wanted a 4, I just type 4 and I'll get a 4 output tile. I'm not quite sure what I'll do if I put a 2 in. Yeah, it gives me a 2. So I'm just typing the key on the keypad. I'm just typing that number. So at this time, I want a 3 because I'm trying to get rid of that alpha channel. Down the bottom here, I can make these automatically connect by doing that. Oh, it's connected all of them. That's great. That's pretty super, actually. To move the, so it's what it's done there. It's determined that there are 4 outputs, 3 outputs required. So it's put in a pack component and it's mixed them all with a mixer. I just did that by doing an autocomplete. That doesn't always work, but it did in this particular case. One thing that's happened, it's slightly weird, is this is kind of on that side. I often go in and neaten my trees, and the way you do that, you move a component by hitting Shift and either of the, what you call those keys, arrow keys. They're not arrow keys, they're the angle bracket keys. So if you hit Shift and use the angle bracket keys, you can move your components left and right. You can move them up and down with the O key, if it allows you to, it doesn't there, and down with the U key. It won't allow them to move if it doesn't have a reason to move them. But if I put in another component over here to the side, and I wanted to move it down to the bottom, I can do it. That was just hitting the O key, and I can move it back up with the U key. That's basically how you navigate around with these things. And delete it with delete key. So this has mixed our 3 Gaussian circles together. They're obviously all on top of one another, and they're all the same color. But I can offset them. So I'm going to put in, damn that. I don't know why it does that. It's what I did then was actually putting in a tile above this one, and I expect that it will put in a 3 in, 3 out, but it doesn't in this case. It puts in a split component. I'm not quite sure what the logic of that is. It's a bit irritating, but so it means I have to manually do this, which is slightly annoying. So 3 in, 3 out. I'll just reconnect that one. I'm putting these in here because I want to be able to move the dots. I'm going to turn them into tiles that will move them in a sec. Okay, so all I've done, and I'll put some offset tiles in here now. So all I've done is I've actually put in just some, these are 3D space transforms basically. So they're the same as the 2D space transforms, which you would use if you were just using the little Gaussian dot 2 in, 1 out one. You'd use two out, 2 in, 2 out transforms. But because we have 3 here, I'm using the 3 in, 3 out. I could actually just use a 2 in, 2 out and use the top, the left 2 things, because that would work. But for the purposes of this, I'm going to use all 3. So I can actually move this in the Z dimension if I want, but I'm not going to do that because that'd be very confusing. So I'm just going to offset one of these dots to one, whoopsie, let's go the other way, to one side. And I'm going to offset the other one to the other side. Okay, so this makes sense to you, right, what we've just done. Okay, we've taken 3 colored Gaussian dots. We gave them all a color in our color cycle. We've mixed them together with a packed component, and they're all being mixed with a packed RGB additive component. So it's using the additive values of each of the 3 dots. So let's go ahead and we'll just change the colors of them. So we've got 3 different colored dots, and you can quite clearly see that we now have control over these 3 dots' color. That's one thing that we can control. So let's lock everything. Let's see how we're sitting here. Everything is actually locked. Just check that by hitting Shift and then relocking. And I'm just going to unlock the color cycle. So the only thing that's unlocked is the color cycle, which basically means that's now open to mutation. So if I click on the tree, I'll get 3 dots, and you can see that they're all, that one's not mutating. Why is that? Because I only unlocked the color cycle on one of them. That would make sense. I've got to do it on all of them. So yes, that's better. So it's mutating the color cycle, only the color cycle on each of these 3 dots. This component is mixing them all together with additive values, but I can actually find some other different ways of mixing them together. I can just mix the max values. So the additive values is actually picking up a little bit of background, which is why it looked a little bit gray. But you'll see what the difference is if I just move these so that they overlap slightly. I love max value add combinations because it's a really nice effect. They give you that kind of nice squishy effect. See that? Whoopsie. But you can see that the color values are also being added here. I really want to try a face with these. This would be really nice. And I'll change it so that you can just see what the additive one does to that as well now. Oops, here is an add. So it's a very different color effect, adding them and multiplying them. Oh, that's a memory add, that one too. Let's try a packed add. That's added some of the background as well, but it's very different kind of effect to the multiplication, the max value. You can have a crossfade, which just crossfades between them. These mixes all have different kinds of things, and you can also have max value. You'll see that there are some of the things are already inside there. They weirdly act differently inside the maths value. So the multiply inside the maths value adds differently to the max. Well, actually, it's a different function really, so that's okay. And there's one more, which is the memory differential, which gives, actually the memory functions won't work properly unless you've got some kind of memory thing going on. So anyway, that's a mixer, which is mixing them all together. The values that it mixes them to are controlled here. So it's adding whatever value. Actually, that's probably going to be easier to see if I use a max value. So that's just the pixel values of whatever you're adding together there. But otherwise, it will all be equal. And I'll just lock those again. And now the next thing I'm going to do is I'm going to put in above these, I'm going to stick a, no, let's put it below because then I won't have to put in another component. I'm going to put in a noise component in each of them. And you can see it's actually mutating the noise function and the color, interestingly. But if I change the phase, you'll see the shapes will change as well. And so I have, I'm not sure why it's doing the color. It's because it's offsetting it somewhere. I'm going to leave those unlocked. Actually, I'm going to lock those. Obviously, things that are unlocked are going to mutate if we use the random value. At this stage now, we only have the color values and the noise phase unlocked. So when I go in here, I should just get, why is that not happening? Phase. I must have locked them again, did I? Just unlock those. That's better. So what's happening now is that you're getting a controlled mutation on both the color and the phase of the noise. So the phase of the noise is controlling the shape, and the color obviously is controlling the color, which gives us the option to just kind of make lots of variations of our funny little squiggles, but they kind of have the similar sort of controlled look to them. They're just mutating some things. So you're not getting that wild, weird, free-for-all mutation that you often get when you're using ArtMatic to just mutate stuff. You've got a control over it. And where you can kind of really bring this into a really useful kind of exploration is to do something like stick a mirror on top of it. So we have an n-fold mirror with 6 variations to it. So I've locked it all. And when we go into the mutations now, we get a whole lot of different variations of that particular kind of noise thing. So you can kind of see there's a way forward here to create, really nice controllable systems where you're getting a little bit of expression coming in from the software as well, where you've got something that's got this kind of symmetry to it, but it's also got this bit of wildness to it. So you actually have control over what kinds of things you can go on to build from that. So we're kind of getting close to the time now. So I'll leave it here for the moment. I was intending that we would go into loopers, but maybe we'll have to leave that for a bit, because going up that next step into being able to loop your functions gives you this other really fabulous kind of level you can go to whilst you use this constrained mutation and looper functions and these lovely symmetries. You can just start to create shapes that have got kind of organic, symmetrical abilities, that kind of look like organic things, and you can start to refine how precise they are, and you start to look at things like you start finding things that look like flowers or insects and so forth. So I'll leave it there for this time. And are there any further questions that you'd like to ask, or anything you want to talk about?
Is there a way to insert between 2, 3 in, 3 outs, one that is 3 in, 3 out, or is it always going to mangle it and require manual fixing?
Sorry, between a...
Well, I saw them several times. You inserted a new tile between 2 existing 3 in, 3 tiles.
Yeah.
And the new tile was 2 tiles, or
oh yeah. So what I was doing here. So normally, if you've got, let's just go. I'm going to make a branch tile here. I'll just turn this into a 2 in, 2 out. 2 in, 2 out tiles. If I was to select a tile above it, it will make a 2 in, 2 out tile.
Yeah.
Yeah, it's what I would expect it to do. For reasons that I don't understand, if you do this on these tiles, it works there. But it, for some reason, wasn't working above
Before.
this one.
Yeah.
It was splitting.
Yes, that's what I was getting at. There's no way to prevent that from happening.
No, I don't even know why it happens. As far as I can tell, there's no logic. I mean, it could well be that it just says... so
logically, yeah.
If you're using a tile component, let's take our symmetry away here. If you're using a tile component here, and you just wanted to, see, we're actually only in Cartesian 2D space here. So what's happening is it's giving me the ability to control the XY axis up and down. So the X and Y here will just control where that goes up and down. Right? It's mutating under the noise, which is a little bit undesirable, but I don't want to change that. But also it will enable me to have a separate control of if I use the offset and the Z-axis, it's moving back and forth. No, it's controlling the color there for some reason. I don't know. That's Eric logic. I don't know what that is. I can't explain it. You would expect most of the time it will the adding things above will behave the way you expect. You'll get a 3 in, 3 out tile. That's what I expect to happen. If I had 2 inputs, I'd expect to get a 2 input tile. And if I add one below, I'd expect to get a 2 output tile. You can split the components anyway manually by just holding down Option and Split Component, and that will allow you to do a manual split of the component anyway. So if you need to do it manually, there's a way of doing it. It's just sometimes there must be logic there as to why it happens. I'm just not quite sure of what it is. I can see a reason why you might do it. And it's quite useful to be able to control the color with the offset. I've got to say, you could send something into that. I'm not sure what that's doing. That's controlling. That's actually an interesting situation that's going on there, because it's controlling values that I wouldn't expect to. But yeah, whatever. It's weird. So yeah, so I guess if you wanted to kind of develop, one step further onto this and just kind of get your hands on this yourself, see if you can find those monster face tutorials. In fact, I'll put them up on the Worlds of ArtMatic.
Yeah, thanks.
Because I went through and I did them piece by piece. We built up a very simple face, and it tells you most of the things that we looked at today, but in a much simpler way. And it also shows you how to use the constraint mutation in a much simpler way. And you can probably, if you build that system yourself, I think you'll get a very good handle on how useful it is to be able to control those shapes. And the other thing that it teaches you too, even though it's not apparent at this point, is that if you can understand how you can do that with these 2D objects, when you come to building objects in Voyager in 3D, it's the same principle. It's exactly the same principle, except you have some different kinds of tools to use. But essentially, if you can put together something that's a bunch of 2D Gaussian circles and make something with that, then there's only a very small step from there to be able to do it with a DF sphere and DF shapes to make your own objects in Voyager. Any other questions?
Sounds good.
No, I think that was very comprehensive. It's just takes a time. I get a sense that well, let me ask this question. How long have you been working on that system?
Well, like most things that I do in ArtMatic and Voyager, it's a hobby for me, so I only can do it when I have the time. At the moment, because we're in isolation here, I've got all the time in the world, so I can play with it ad nauseum. But over the years, remember, I've been with ArtMatic since version 1, so that's got to be 20-something years, right, John?
Yeah.
Something like that. And so I first made that face as a challenge, as I said. Someone on the Topica list said you couldn't make a face, and I just went, well, I'm sure you could. So that's when I first did it. And then over the years, I played with it, at various times. But to be honest with you, I haven't touched it for many years. So I just pulled it up again because someone asked something similar on the Worlds of ArtMatic page, and I just thought, well, there you go, have a look at that. It's you can see it could be infinitely absorbing. There's many places you could go with that system. You could keep on playing with that system forever. So there's it's got so much potential. But the thing to think about is it's great for building something like that, but it's also great for just understanding how to build anything in ArtMatic. You remember, I'm just building that whole thing out of those Gaussian dots, Gaussian circles, but you've got other building blocks. There's many other different kinds of shapes that you can use to build things together. So there's just as always an infinite number of possibilities to what you could actually do if you set about doing it.
I think that's a great description of Designer and the whole ArtMatic system and engine.
Yeah.
It's that as you explore with it, you can go deeper and deeper and build up these systems and sort of have them as templates for doing work in the future.
Yep. Yep. Good. And we will go into, we'll go into some more in-depth things later, I think. I think next week we're going to just do a little bit of a tour around the Voyager interface. But the thing that I'm hoping that people will understand as we go along with this is that you'll start to see how the synergy between the two things work. So you understand, well, this is how Designer does its thing, But it's also applicable when we get to Voyager. There's just a different way of thinking about it now that you've got that third dimension to play with. So once you get your head around how to build systems in Designer, and you understand certain kinds of things, you'll start to see, they'll become familiar to you. Oh, okay, so I need to make a lumpy sphere. Okay, well, I need to use some noise functions. To make it work in 3D, I need to use 3D noise functions, but I'm familiar with that because I've already used noise in 2D to make 2D noise functions. So what you're seeing in this particular system here is we're using a 2D noise. Well, actually, we're using a 2D component of a 3D noise to vary a shape. Well, it's exactly the same when you get to Voyager. You're using the 3D component to vary the shape in 3 dimensions. So there's many similarities. Once you pick those up, you'll start going, oh, I can make all the connections and see that, you know, that's not as alien to me now as I once thought it must be.
Cool. Thank you everybody for joining in.
Yeah, thanks guys. Good to see you there.
Experience.
Yeah.
Look forward to having you guys each week. I think the more that people get to ask questions, we'll get to see where the greater interest is, and we can always tailor this program to what folks are looking for.
Yeah, well, thanks for
Excellent.
coming. It was good.
Thank you. It's good. It's very enjoyable.